So what happens when contaminants get into our groundwater? If you're thinking out of sight means out of mind, you are very wrong. Let me tell you why. You see, rivers act as groundwater collectors. Groundwater tends to discharge out of the riverbed and into the river. Sometimes, however, this process is reversed, so river water can seep into the ground. This happens when river levels are quite high, so during a spring melting event, for example, or when a river is influenced by large tides. What's interesting here is when these different types of water begin to mix. So we have river water, rich in dissolved oxygen, seeping down into the sediments, where the groundwater is very oxygen deprived. Now the sediments host a diverse community of microbes, and this variable exposure to oxygen over time forces them to be flexible. As it turns out, many of these microbes are pretty good at degrading or breaking down contaminants, specifically organic contaminants. And by organic, I mean the type of chemical you might associate with an oil or gasoline spill, or in the case of our research, a mixture of chemicals known as creosote. Creosote has long been used as a wood preservative at sawmills and lumber yards. However, up until about 40 or 50 years ago, environmental regulations at sites like this were weak or non-existent. So creosote spills went undocumented. There exist a few sites along the Fraser River Delta here in the Vancouver region where creosote contamination remains an issue. Now there's a strong arsenal of remediation techniques to ensure that those contaminants don't reach the river, but we study the processes of natural attenuation, or the way in which a contaminant breaks down naturally in the environment. This is really important for the sites that have yet to be cleaned up. Our research is driven by a few important questions, like can we predict how and where a contaminant will seep into a river? What's the chemistry and the microbiology of the sediments? And how do these things change with depth? By answering these questions, we better understand how contaminants are transformed on their journey to the river. Now doing this requires some interesting methods. Normally groundwater samples are just taken from a monitoring well, but we're working with a region below a river. So as you can see here, we sample groundwater from a boat. Researching natural attenuation improves our ability to tailor remediation projects to specific sites. Groundwater remediation is more than meets the eye. It requires critical thinking, innovative engineering, and sometimes a little help from our friends, the groundwater microbes.